I will use this battery case that can fit up to 70 pieces of 18650 lithium-ion cells. These are MH1 battery cells by LG with a capacity of 3100 mAh and a maximum continuous discharge current of 6 amps. Before assembling the battery, I am applying these insulation rings on each cell's positive end for extra protection. This is an important step when building batteries to prevent any short circuits or damage to the cells while connecting them using a spot welder. For this e-bike, I am making a 14S 5P battery, which means 14 groups of cells are connected in series, each group consisting of 5 cells connected in parallel. This configuration will result in a battery with a total voltage of 52 volts and a capacity of 15.5 amp hours or 806 watt hours in total. So in theory, this battery will be able to provide 800 watts of power for roughly an hour. For monitoring the voltage of each group of cells, I am using the smart BMS board with Bluetooth connectivity. It has 2 temperature sensors that connect to the board. I will glue one sensor in the middle of the battery pack using temperature conductive glue. This fiberglass sleeve will ensure that the cable running inside the battery won't cause any shorts between the cell groups. A piece of Kapton tape will hold the sensor in place until the glue dries. I glue the second temperature sensor to the positive end of the battery. With all the cells in place, I can press down the second half of the bracket. To weld the cells together, I am using this secure spot welder. It is a good quality spot welder that I have used on my previous builds with great results. This spot welder is powered by a LiPo or a car battery, so I am using 2 LiPo batteries connected in parallel for more capacity and a higher output current. Before making the welds on the battery pack, I always do a few test welds on dead batteries to see what weld pulse duration gives best results. I am using a 6mm wide and 0.1mm thick pure nickel strip for the connections. With an 18 millisecond pulse, I am getting pretty good welds. Using scissors, I cut up the nickel strip into the right size pieces and start the spot welding of each group of cells in parallel. With one side of parallel connections done, I repeat the same on the other side. With the parallel connections done on both sides, I move to welding the series connections starting from the negative side of the battery and moving my way up to the positive side. Once you start welding the series connections, it is really important to take extra precautions to avoid shorting the cells. Here I am applying a piece of Kapton tape across the welded part of the battery. I repeat the step of insulating the cells that are connected in series and move my way up to the positive side of the battery. As the battery cells are now connected in parallel and series, I am welding these thin tabs on each cell group. There will be 15 tabs in total, 14 tabs from the parallel groups and one as a positive connection from the battery. They will be used to safely solder the balance wires to the BMS board. A strip of adhesive insulating paper is placed on top of the cells. I now check the placement of the balance wires and solder each one to the corresponding group, starting with the black wire on the negative side of the battery. Because this BMS board is made to connect up to 22 groups of cells in series, I need to modify one connector accordingly for my battery. Once the balance wires are soldered to each cell group, I place a few strips of adhesive foam where the BMS board will be. First, the B- cable on the BMS needs to be connected to the negative side of the battery. Once again, I protect the battery welds before doing any work that includes conductive tools or materials. Here I am welding a few pieces of nickel strip which will make a good connection to the B- cable. I can now apply the insulating paper on both sides of the battery. Because the battery case comes with a small charging port meant for small currents, I will replace it with this 3-pin charging port. I make the hole slightly bigger using a step drill bit and insert the charging connector with the wires already soldered. I insert the switch, which will be connected to the BMS board later, and insulate the contacts with a bit of liquid tape. I now remove the power connector from the battery mount and solder wires to the negative and positive terminals. I also soldered the charging port and the battery capacity indicator wires to the battery power terminals. With the battery installed on the base, I connect the positive battery terminal to the power output terminal. I now connect the C- cable of the BMS to the output terminal. This cable also connects to the negative pole of the charging input. I am now connecting the switch wires to the BMS to act as a secondary on-off switch. I insert the temperature sensor plug and the balance wire connectors as well. Using this app, I can now connect to the BMS board and monitor the voltage of each cell group, temperature of the BMS and inside the battery, turn the battery on and off remotely, see the estimated charging time, and configure many of the parameters available. With all the cables secured, I install the top part of the case. Because the BMS board is slightly thicker, I heat the top of the case with a heat gun until the plastic is soft enough to conform to the shape of the BMS. With the screws holding the two parts together, the battery is finished. Before moving on to the e-bike build, I would like to talk about this video sponsor,